Hello everyone, this is Udit again from TechSpark, bringing you another session covering data engineering question and answers. And in today's session, we're going to discuss the persist and cache technique in Apache Spark and what are the key differences between them. So as usual, I'll start off with a brief introduction of myself. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. So before getting into the explanation of the persist and cache, what they are and how they work, let us take a look at Spark DAG. What is Spark DAG and how it works? So a DAG, which is also known as directed acyclic graph, is a model that represents the logical execution plan for a data processing job. It's a series of stages that break down a job into smaller tasks that can be run in parallel. So when we submit a Spark application in the cluster, it gets broken down to several jobs, and these jobs are nothing but the actions that we trigger or we put in our Spark API code. And each and every job will consist of multiple stages based upon the white transformation that we provide. So if we look into each and every stage, then there would be multiple tasks running inside the partition. As discussed in earlier session, that the narrow transformations doesn't create any stage and they work upon each and every individual partition. So those transformations that are working inside the stage is known as the task, that is the smallest unit of Spark processing. Now suppose these tasks or the transformation that I provide in the Spark API code, that I'm reading a data frame, or suppose I'm reading a file and converting into data frame, then doing multiple narrow transformations or wide transformation for that matter into the same data frame and then creating a resultant data frame. Now suppose that resultant data frame I'm using it for multiple purposes. Like I want to showcase the data. So I call the show method to highlight the difference, to highlight the attributes and the columns. Or I can even take the full count of the data frame by calling the count method. Or in fact, I can use the data frame to join with another data frame to get some more insights. So the fact of the matter is I can use that data frame for several purposes, and each and every time I call upon the data frame for any other method, in that case, this whole tag will run again. What I'm trying to say is that if I have a data frame that is being constructed after multiple transformations, and there are three different methods that I'm calling into that same data frame, that is show, count, and say join with another data frame. So in each and every case, that data frame will be created from the scratch, the way it is being created after reading the file, then applying the transformations and whatnot. So basically, we're doing all the work three times over here. Okay, so we read the file, we do multiple transformation, we create the data frame, we call show. Next, when the df.count is being called upon, in that case, again from the scratch, it is reading the file, creating the data frame, applying the transformations, then calling the count. Again, for the third task, that is the join. Again, the same thing is happening. It will read the file, create the data frame, apply the transformations, and then do the join. So you can understand that there is no need to do the same things over and over again, because these are the similar tasks that I am doing. And just because I am using the data frame, same data frame over and over again for different purposes, it is creating the DAG, or it is kind of like processing the DAG all the times whenever I call upon any other action. To avoid this, Apache Spark comes with two different phenomena. One is caching, the other one is persist. So in Apache Spark, cache and persist are two mechanisms to store intermediate data in memory or on disk for reuse, improving performance when multiple actions or transformations access the same data. So this is just what I said, right? That when I create the data frame after say a lot of processing, and I'm going to use the same data frame for multiple other purposes, then in those cases, I don't have to read the data from the scratch again. I don't have to process the same transformations that have been applied earlier. Okay, so just to simplify the terms, is that if I have a data frame and I want to use it over and over again, in that case I can use one of these techniques, that is the cache and persist, to store that data frame into an intermediate storage. Now this could be either memory or disk. So that depends. That depends on different parameters. But the fact of the matter is, if I store the data frame into an intermediate storage, in that case, whenever I call upon multiple other actions or transformations from that intermediate storage, that data frame will be called upon. It won't have to, read from scratch and do all the things again and again. So that's how the caching or the persist helps. Now let us look at the difference between caching and persist. So for caching, it stores the data in memory, that is the RAM. If the data cannot fit into the memory, it spills the data to the disk. Now, why the data cannot fit into the memory and how it's gonna spill into the disk is we will understand the whole structure when we go to the memory usage part in the Spark. So that I'll cover in one of the latest sessions. So Spark has a memory management in a way that Spark does all of its processing for a fraction of its memory, and the other fraction is being used for storing the intermediate results. In some cases, the intermediate storing fraction may get overpopulated or it may get overflowed. In that case, if there is no space left, in that case, it writes that cache data into the disk. In that case, it could be problematic for the job because of the fact that whenever it is the data is being stored in the disk and then it will try to read the intermediate data from the disk, there would take a toll on the IO throughput. That would hamper the performance of the job. That would slow the job a bit down. So these are the challenges that comes into place whenever we are storing the data anyhow in the disk. Okay. Secondly, it is often used when a data set is reused multiple times during computations. Okay, this is what I just explained, right? That if I have to reuse the data frame over and over again for different other purposes, in that case only I'll be using the cache. So caching by default stores the data into RAM. There is no configuration or option as such that provides us that we can store it otherwise. But it is much faster than Persist because by default, if it stores the data into memory, then the retrieving the data would be much easier for Spark job. And because of this in-memory functionality, it's gonna help in retrieving the data much faster than Persist. Okay, so if you look at the diagram over here, so what I just explained, right? It's creating a data frame out of a CSV file. So Spark is using the read API and then calling the CSV method to read the data.csv file. It might be stored in Hadoop or in cloud storage, whatever. Then right after that, I'm caching the data frame. Okay, why I'm doing that? And in between, there could be different other action or transformations I can perform. Okay, it could be like df equals to spark.read.csv. Then I do some filter. Then I do say some map operation, group by, join, whatnot. There could be multiple operations before the df cache. So once I cache this result, and after that I'm using the same data frame, that is the df, for other multiple actions or transformations, such as I'm calling in count or show, or probably there could be other transformations as well, such as join or group by. I can use it for different purposes. The fact of the matter is, whenever I use this word cache, in that case, the data frame is now stored into my memory by default. By default, I'm saying because it can get pulled into disk, it can get spilled into disk whenever there is a shortage of memory inside the RAM. Okay, so by default, it will try to read it from the RAM and then it will do its all operations that I'm calling in afterwards. So this is how a cache works. So just highlight these things or keep it into mind that cache by default will store into the RAM. Now, let's come into the persist. So persist method provides more control over storage levels, allowing you to specify where and how the data is stored. Okay, so there are some examples like memory only, disk only, memory and disk. So let us look into each and every option that are provided to us. First is the memory only. Stores data only in memory. If not enough memory is available, recomputation happens. Okay, so this is much like cache. So whenever I try to call in the persist method, then I am given with multiple options or configurations that where do I want to store the intermediate result. So if I pick the memory only, then it is going to store the data in memory only. And obviously, if there is not enough memory available, in that case, the recomputation happens. It will be spelled into the disk, or sometimes you may see an out of memory error. But the fact of the matter is that I am here forcefully just putting the data into memory. Coming to the second option, that is the memory and disk. It stores data in memory and spills to disk if memory is insufficient. Okay, so that is default for cache. So in the cache, I don't have to mention in the configuration. By default, this happens, right? It will try to store the data in memory, otherwise it will spill into the disk. For the memory only action, the problem is if there is not enough memory, it won't spill into the disk. Okay, it will simply try to do recomputation to get more memory out of it if possible, else it will simply throw an out of memory error. Okay, third one is the disk only. So disk only will store data on the disk. This is probably one of the worst configuration Persist can provide and can only be used if there is no other option. If I know that I don't have any memory or the memory fraction, I'm using most of it for the processing purpose and not for storing intermediate result. Because whenever I'm putting the data into disk, the reading from the disk, it will automatically increase the IO throughput, which takes a toll on my Spark job. The fourth one is memory and disk SER. This SER means serializable. So this will store serialized data in memory and spills to disk if necessary. So this serialization means, as I have already explained in one of the earlier session, that data will be converted into a binary format and then it will be stored. So this binary format data is already compressed. So the actual data, whatever it was taking a lot of space, in this case, it would take a little less space. So it will store the serialized data in memory and it will spill the disk in necessary, and also in the disk it will be in serialized format only. So this is still a better option. This is obviously a better option than disk only. In fact, this is also a better option than memory and disk, because in memory and disk it's the same thing happening. The only difference is the data will be stored in its original format, not the binary format. And since the original format takes a bit more space than the serialized format or the binary format, so if I consider the compression to be at an optimal level, in that case memory and disk SCR would give me a better performance, even though it would take a time while retrieving the data, because if I serialize the data, then obviously when I call it back, it has to be deserialized again. So it takes a toll on the IO throughput. So there are different parameters I need to keep in mind, that if I want to put the data in a compressed format, no matter what, I know I don't have much memory in my each and every executor. In that case, I should go for memory and disk realizable, because at the end I'm pretty sure that it will compress the data as much as possible whenever we convert the format from original to binary. But at the same time, if I have to consider the IO throughput, retrieving the data as and when possible in a quickest way, in that case, if I serialize the data, the deserialization would take a toll on the IO throughput. So these are the parameters that I have to keep in mind whenever I'm putting any configuration for the persistence. And the last one is the off heap. So off heap is a space that is there in the executor memory that is being used for other daemons to run or for other data structure to store. So in this case, if I put this configuration, then the intermediate data film or the resultant data set will be stored in the off heap memory. This also requires proper configuration. While we submit a Spark application, we also have to give the memory overhead or the off heap memory. So we just have to make sure that there is a significant amount of space that has already been assigned. So out of all these options, memory and disk serializable would take a very less space, but also it would take a toll into the IO throughput. So memory and the disk is something, the second option is we can use, but we have to very specific about the requirement and very specific about the cluster resources, that how we're going to deal with the cluster resources that has been provided to us. So now if I talk about the basic differences between the cache and the persist, in that case, it is pretty evident. The cache is going to store the result in the memory. It doesn't give us a lot of options. But at the same time, we are pretty much sure that our job is gonna be much faster because it will try to store the data as much as possible into memory, and it will only spill into disk whenever there is not enough space. But in persist, we have to make sure that where we put it. By default, if I don't put any configuration, then this is by default memory and disk. Okay, so it will store the data in the memory and then it will spill into the disk. So that is the same as persist. But I believe persist gives us much more options, and also there is a keyword called unpersist through which we can clear off or we can clean the memory once it is not being used. Suppose I have done all the processing and I don't want to use that data frame anymore. Then I simply have to just call df.unpersist. The similar way I'm calling df.persist. So once I call the df.unpersist, in that case it will clear off the memory that is being held for intermediate storage. Okay, so this is all about the cache and the persist and what are the difference between them. So we are covering almost everything about Apache Spark, Hive, Hadoop, AWS into our comprehensive course that is being provided from the TechSpark. So do reach out to us for any query, how to set up local clusters, Hadoop cluster, Hive, and Apache Spark setup, everything, Databricks, and also we're gonna help you with the hands-on coding and the real-world project. We're gonna introduce you to the AWS cloud. We're gonna see how a data engineering project uh, is possible end to end in the AWS cloud using the AWS services. So just reach out to us for any query and we will help you. And we also provide 100% job assistance. We will make a profile interview ready for you so you can crack, not only crack all the interviews, but you will have an in-depth understand for each and every topic that we cover. So signing off for the session. Bye bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpark.